So in this first example, any suggestions? Quickly, yeah.
Make two forms of the equation. One, if x plus 1 is greater than or equal to 0,
Okay.
and the other one makes the opposite.
Good. But before that, I want you to do one thing. What do you think? Isolate the absolute value. Okay, let's do that. So that we have absolute value of x plus 1 by itself. And that's going to equal 3x minus 2. How are we doing? All right? Then, as was just mentioned, you have your two options. Why don't you guys try that, work together, see what you come up with. Then I want those whose birthdays are January, February, March, April, May, June. Check this answer. And the July through the December birthdays, you check this answer. Back in the original. Alright, so you first half of the year birthdays, did your number work? Did 1/4 work? Well, no, it did not. Okay. Did 3/2 work for the last half birthdays? Yes. So I guess if it works, you're more confident, huh? But if it doesn't work, you're going, maybe I messed up somewhere. I get it. Now, did anyone catch something to kind of give you a clue that the 1/4 wasn't going to work? See it? This path happens when this is true. Or similarly, when that's true. Is that consistent? No, it's not. Whereas here, this is consistent, so it's going to be okay. Things to look for. Alrighty, so let's go to y equals, and let's pop in those two functions. First is x squared subtract 2.2x, enter. And the second is y equals 0.8. Enter. Okay? And so really, right, what they're doing is if they both equal y, they equal each other. So they're really doing this, aren't they? But in a different way. So if we go back to our calculator, and let's do a zoom 6 for standard graphs, we all see the same thing. And on our notes, it's a system, right? Y equals this and y equals that, meaning What do they share, right? So if I go to second and trace, which is the calc choice, now I will use 5 for intersect. You'll see your screen says first curve, and all the blue stuff shows up on my screen. That's the first equation. Just press enter. Now we're on the red graph, or the second equation, y sub 2. Just press enter again. Now we want to guess the intersection. Well, there's 2 of them. You can only do one at a time. So you can move your arrow to the left, close to that one, and press enter. And boom! Are you surprised? Y is 0.8. That's what it said for the second equation, right? Let's do that again. It was so much fun. Second, calc, intersect, first curve, second curve. Now for our guess, you could use right arrow, right arrow, right arrow, but let's try this. I think it works. Type in 2, enter, and it moves it faster, doesn't it? So it's close to 2, and there it is again, 0.8, but the new x value. For this question, the way it's worded, do I want just the x value or the x and y value? The way it's printed. I think you're going to want the x and the y in both cases. Now you're right. It's kind of boring. The y is going to be 0.8. But, if it was worded this way, which do I want? Just the x. Just this and this. First of all, we graph it. No big deal, I hope. Just plug it into the y equals stuff. And let's do a zoom 6. We'll see the same graph. There it is. Alright? Now, I realize that the notes are kind of bad. It says, how would you do this algebraically? Do what? Right? So I think what they're getting at is we ought to graph it, and we want to find, like, watch the words, the zeros. This is different. Okay? So since your notes say find the x-intercepts, it's finding the zeros, because zeros mean what are the x values that make y 0. So the 0 has to do with what makes 0. We don't plug in 0 for x. See the difference? Okay. And yes, then we want to find the x-intercepts. And so we do the same thing, except this time we do second, calc, and we do 0. Left bound, again, if you don't want to do the arrows, you can do like a number, like type in 2 and press enter. Oops, wrong way. If you want to type in, let's see, -2, enter. You're now to the left. Oh, I just messed this up totally. How about if I do second, calc, 0, left bound, -2, enter. So we're over here. Right bound, let's say is 0. And guess, let's say we want to say like -1.2. Enter. And we weren't very close. It was -1.4. 14214. Anybody know that number? Might be root 2, huh? Maybe. And if we do the other side, looks like there's symmetry here, right? What do you think the right one will be? Positive root 2, maybe? All right. Let's see. Algebraically, I think there's factors. So, boom, 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 boom. And if I want to find zeros, or find the x-intercepts, x squared, 3, 2, plus, minus. Here, you're going to have a squared equaling a negative. Not going to do that yet. Here, we'll have x squared equals 2, root both sides. Technically, the left-hand side is what? Absolute value of x. But we always skip this step, don't we? We just jump right to x is plus or minus root 2. Surprise, surprise. Alright, so for the first one, what I would do is isolate the x minus 1 to the 5th first. And I believe that's negative 16, is that right? And then we root both sides by the 5th root. And we get x minus 1. And my question to you is, do we get plus or minus? No. 2. 1. It's an odd root. Second, how do I make a negative an odd number of times? A negative times a negative times a negative times a negative times a negative, and only that, right? If I do a positive, it's not going to work. So this is going to be, if I wanted, I could do this, right? Negative 5th root of 16. And also, a 5th root is okay with having a negative underneath, right? So then, I kick the 1 out of there, and here's our final answer. In exact radical form. The 5th root of 16 is the 5th root of 16. I know 16 is 2 to the 4th, but 2 to the 4th isn't big enough, like power-wise, to come out as perfect. And then we can do 1 subtract 5 math. You see the choice 5 here? I put a 5 in earlier before I went into this, so that the 5 I put in earlier will be the root for choice 5. See that? And then 16, and then enter. And we have a negative 0.7411, etc. The directions say rounded to 2 decimal places. Now, I know there are rules. I know that. But here's what the rules mean. You know me. I'm all into meaning. Which one's closer? This one, right? And so that's what we mean by rounding. We get the closest to 2 decimal places. Now, I know. You look to the right, if it's 5 or less, you drop it off. I know the rule. Okay? But I want you to be aware of where the rule came from. Next one, you may have tried to factor this and got stuck. So instead, we use the quadratic formula. What is being squared? X squared. So x squared equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Cleaning that up a little bit, do you see root 20 under the radical? I think it's 36 minus 16. And cleaning up that some more, it's going to be 3 plus or minus root 5, because 20, right, is 4 times 5. The 2 pops out, and the 2 is going to knock it out. We need to look at this problem like this, and now it's a quadratic. This is the thing that's being squared, that's why it goes here, and the coefficient is 1. I see why you would think it would be x squared, because it's x squared times x squared, but that's not then, that'll mess this part up. Okay. Now we're not done. X equals what? Now it's plus or minus, correct? And you would think we were done. And luckily, you're right. But luckily, I want you to be aware of one small thing. You see this? This is dangerous. Because if I subtract, and this is bigger than 3, for real numbers, am I allowed to have a negative under a radical? No. So what you might have to do in other problems, bless you, is to change the plus or minus only to a plus. Or maybe in some cases only to a minus, depending on what's going on under the radical. You got it? Okay. Last one. This is factorable with some clever thinking. There's another way to do it, I'll do it in a second. Is this going to work? When I multiply these two, do I get the 6? And then when I multiply two expressions with x, don't I keep the base and add the exponents? And that's negative 2, right? So that's okay. And then I make 2. How about if I put a 2 here and a 1 here? And this combination is 4, x to the negative 1. This one is 3, x to the negative 1. So I believe I want the 4, 1 to be negative and the 3, 1 to be positive, right? So then I get 3, x to the negative 1 minus 2 equals 0. I'll skip a step if you don't mind. And who remembers what negative exponents represent?
It means that it's like 1 over x.
The reciprocal. So what reciprocal gets you 2/3? 3/2. And the same thing here. I get 2x to the negative 1 equals negative 1. X to the negative 1 equals a negative 1/2. And the reciprocal of that is negative 2. For that one, I don't think we need a decimal approximation, do you? Now, here's another idea. 6, what's the reciprocal of x? 1 over x. What's the reciprocal of x to the negative 2? 1 over x squared. Or I should say, what is the same thing as x to the negative 2? Is this the same question? Then I can clear the fractions. And I get 6 minus x minus 2x squared equals 0. Is that right? And then if I rearrange and play with the signs, is everyone okay if I do this? And it's very similar, to what we just did. The 2 and the 6, though, switch places, but that's okay. We can deal with it. I believe we get the same thing. So, yes, you can do it either way. I want to do it this way first, though, so that you have to think about negative exponents and what they meant, as opposed to just getting rid of them and ignoring them. All right? So going back to the one above, we forgot to do the decimal approximation. If it's okay with you, I'm going to put in the plus or minus. We can do that in our heads kind of thing. And then we would do second radical 3, and you would do them one at a time. Do the plus first, and then do second and radical, and 5, jump out of that. Yeah, and here's one of them, but actually those are 2 of them, right? Because you would plus that and minus that. Then we'd start over again, and let's see, I think I can do the second, do that. I did second and enter and brought back the last step. I think you can also go up and do that. Then go back and make that subtraction, and press enter, and you would have to do plus and minus of that also, right? Meaning there's going to be 4 solutions. 4 solutions.